Hi, my name is Cosmo Pecchioli and I'm with Alfa Laval Data Center Cooling Solutions. And the title of this video is the importance of designing plate heat exchangers for the actual operating conditions. So today we discuss about flow rates and how they influence your heat exchanger long-term performance. In particular, we discuss shear stress of the fluid in the channels and what it means in terms of fouling resistance. We at Alfa Laval work with many data centers, and we regularly see heat exchangers that are designed for a specific flow rate, but then subsequently run at a much lower flow. This is often done with a mistaken idea that when they need a higher flow rate, the unit will be ready for it. Cooling systems for server rooms are often designed to cool down the room when it is at its capacity. Unfortunately, when the server room is brought online, it's rarely at its capacity. Servers are added over time, so for the first couple of years, the cooling system is very oversized. The problem of some oversized equipment in the system can be moderated with ancillary equipment. For example, you can put a variable frequency driver or VFD on a pump and slow it down without any significant drawback. And the same goes for your chiller. Unfortunately, you cannot put a VFD on a plate and frame heat exchanger, but other things can be done. One of the plate heat exchanger's great strengths is its ability to easily alter its design to match operating conditions. This is accomplished by adding or removing plates. You can design the frame for the full room capacity, but install only the number of plates for the actual heat load when the room is commissioned. This is the equivalent of a VFD for a heat exchanger. As the load goes up, you add as many plates as needed until you reach the maximum specified design. And it's such an easy solution, but it's yet almost never implemented. People are reluctant to alter equipment that is already installed because they do not realize the ease at which this can be accomplished. What is not taken into consideration is that if you run the heat exchanger at less than the nominal capacity by dramatically lowering the flow rate, the shear stress in the fluid channel is going to be so bad that unless you have water coming directly from a pure alpine spring, you are going to increase the fouling rate exponentially. In theory, you can use cleaning in place, you can use backflush valves, fluid recirculation, and other fantastic options. But in real life, we see that people inevitably end up fouling their heat exchangers enough to force them to open and mechanically clean them by power washing the plates. So you end up doing more work than you would have adding plates when you need to increase the capacity. You also have to clean the units time and time again because without adjusting the plates, the units will continue to foul at a greater frequency. Even worse than that, your heat exchanger performance will also be below par between the cleaning. Of course, every location and every project is different. So when you design a solution, please get in touch with us and let's have a chat to see what kind of flexibility is possible. You will make your life and the life of your client much easier.